Hello and welcome back. In this video we're going to look at the updated list pattern. If you recall, lists are mutable, which means we can pass data to functions and the functions can then modify the content of the list rather than creating entirely new lists. If you remember the mapped list data pattern, what it did was it received a reference to a list, it then created a new and different list and populated that new list based on the elements of the original list. An updated list pattern instead is going to work on and change the content of the original list without creating a new and different list. So, for example, if we want to write a function that scales up all of the numbers in a list by a given factor, well, we've got a first obvious attempt on the left and on this slide, and unfortunately it's wrong, and we're going to look briefly at why it's wrong. So, our function scale up receives a reference to a list and it receives a scale factor. How much do we want to increase the grades for each of the elements in this list? And what we'll do is we'll use a for loop to march through each of the elements in the list. So for num in nums, that's our list, we're going to assign to num whatever the original num was multiplied by the scale factor. So naively this might seem correct, but let's see what happens when we run it. We start off with an original set of marks that are 55, 37, and 85. We print out what those marks are. There we are. That's what we see here. We then call the scale up function, passing in a reference to marks, and we say we want to increase all the marks by 1.2. And what we get after we've returned from scale up is the marks that have been unchanged. So why didn't this work? Well, hopefully you weren't confused by this and you knew in advance that this would be incorrect. But what's happening here is when we have the assignment num equals num times scale factor within our function, so this assignment, what's happening there? Well, we have at the beginning of this function a reference to nums, and that's what the reference to nums looks like. It's a list object that refers to 3 independent floating point values. From index 0 we have a reference to 55.3, from index 1 we have a reference to 37, and so on. Okay, so when we march through our list using the for loop, at the first assignment to num, for num in nums, num will refer to 55.3, so it's referring to the same object as this reference. But what we do as a result of the assignment is we calculate a new value, we run the expression on the right-hand side of this assignment statement, and we calculate a value that is num times scale factor, which gives us a new object on the computer's memory that is 60.6. And then we make num refer to that new value. That's what we see here. So after the assignment statement, we have num referring to an object on the computer's memory that is 60.6. Num no longer refers to 55.3, but if we think about the list object that is referred to by nums, here it is, and index 0 still refers to 55.3. So in terms of our list object, nothing has changed. So what we need to do instead, that's why our program failed, what we actually want to do is we want to have nums referring to this list object, and then we want to change the thing that is referenced from each of the elements in turn. So we want nums indexed by 0 to no longer refer to 55.3, but nums indexed by 0 instead to refer to the new value. So the thing we're wanting to make an assignment to is the index from the list, not just the value itself. Okay, so we're going to achieve this using a mixture of a mapped list pattern and a counting list pattern. So here's our solution. The updated list example correctly looks like this. I'll just increase the size of that slightly for you. So what we do instead, we've got our docstring for a function that looks pretty similar, but now what we're going to count through is the index into the list. So we're going to say for I in range len nums. So this is going to give us a range object that goes from 0 to the number of values in the list referred to from nums minus 1. Okay, so if there's 3 elements in the list, as our example has, this is going to give us the range will give us a range object that iterates through values 0 to 2 inclusive. So the first time through this loop, I is going to have the value 0, and at this assignment statement we'll do the usual thing of first calculating the result associated with the right-hand side of the statement. So nums indexed by I refers to the value 55.3, and we multiply that by our scale factor 1.2, which gives us a value 66 or thereabouts. Okay, 66 is a value now on the computer's memory, and we make nums indexed by I, so the 0th index from nums now refers to that new value 66.36. And then we go through and do the same for the index 1 and index 2 until we get to the end of the list. So this time, when we run this program, we get what we expect. We begin with a marks list that is 55.3 and so on, and we finished with the scaled marks containing the modified, updated marks. So everything works now, which is good news. Typically, a function that is implementing an updated list pattern will not have a return statement. It doesn't need to have a return statement because it's not handing any data back. The mapped list pattern was creating a new list, and it needed to return that new list to whatever called it. But the updated list pattern, well, we're just dealing with the original data and modifying it, so there's nothing to return. So in general, our style rule would be to prefer the mapped list pattern over the updated list pattern. There's more opportunity to get confused with the updated list pattern unless there's a clear and measured performance improvement. So one place where you might prefer the updated list pattern is if you're dealing with massive sets of scientific data. The mapped list pattern will need to duplicate that set of data because it works off the original and creates a new version that then gets populated. So we're going to consume twice as much computer's memory. But in examples like this, and computer's memory is very large, so seldom is that really a substantial concern. So instead, we could implement it using a mapped list pattern like this, which has the familiar format that we start with marks looking like this, we print out what those marks are, we print out scaled marks, and we call scaled up. So this is a mapped list version of the scaling function. The arguments the parameters to the function are exactly the same, so the arguments we pass in are the same. It's a list of numbers and a scale factor. But what we do is we start off by creating a new and empty list, and then for each of the numerical values in the original list, we just append to our initially empty list each of the values that we want. So this tends to be a simpler solution. It's harder to make mistakes in it, and that's why in general we'll prefer mapped list over updated list. Next time we'll talk about sequences and tuples. Thanks for now.